And we're back. It's time to sort it out with Mr. Sort Out. Here we have spring constant from projectile flight. So what we have is a marble launcher with a marble, and it's currently compressed. And then when we release that, it's going to launch the marble, and we can figure out how far it traveled by measuring it. And we also know the height. We know the length of this section right here, which is how much the spring is compressed, and we also know the mass if we need to know that. So let's think about projectiles for a minute. If you remember, in the y direction, we can write this kinematics formula. Then the marble is going to behave like something that's simply dropped in the y direction. So its initial y velocity is 0, its acceleration is g, and if up is positive, then g would be negative, and also your delta y would be negative. So, but rearranging for the time, we got this expression for the time in air, so that depends on the vertical height and little g. Then you're able to launch this marble. So when you do that, you'll go ahead and measure delta x, and that'll be where it lands along this ruler. So what we do not know is its speed leaving the launcher. We know that it will take a given amount of time to hit the ground, and then we can measure how far away it lands. So we actually need the velocity, so that would be the distance divided by the time. If you want to put that all together in one big formula, that's this, or else just take your time and plug it in down here. All right, then, as it's leaving the launcher, it has that initial velocity in the x direction. It's all the velocities in the x direction. So, to find the kinetic energy at that point, simply do 1/2 mv squared with your result from here. Then let's think about, we're changing energy from what was stored in the spring to then kinetic energy of the ball. So in the initial state we have the spring all compressed, and then in the final state we have the ball in motion. So let's set those two equal to each other. Spring potential energy is this, and then kinetic energy is on the right. Okay, then we actually want the spring constant. So we solved for the kinetic energy, the moment that it left the spring and then it left the table in an earlier step up here. So I kept that as a variable here, and then for the spring constant, that will be given by this expression right here. Be very careful, of course, when you're dealing with springs. Often the compression is really small, so here this was in like millimeters up here, so make sure to turn that into meters before putting that in your calculations. Okay, that's what you need for that.